Good morning, everyone. Thank you for joining us in lockdown for another Dental Axess webinar. I'm Matthew Thompson. I'm the Technical Product Manager at Dental Axess, and today I'll be talking about clear aligners the Dental Axess way. So, what are we going to be covering today? First, the opportunity with clear aligners, then how to make clear aligners, specifically the design workflow, some workflow integrations, and the costs and efficiencies. So first up, the opportunity. As many of you will know, there's an enormous market out there for clear aligners. There's many companies popping up recently since various patents have expired in the past 2 or 3 years, and the market is absolutely taking off. Lots of clinics and labs all around Australia and New Zealand and other people we speak to all around the world are really interested in doing clear aligners and having it as something they can offer their customers and their patients as well. So we see this as a good chance to discuss how a clear aligner is made, what are the options, some are cheap, some are expensive, and just how you can integrate it into your business. So we've got the costs here very briefly. Leading aligner provider, we don't want to be naming any names, but you can see it's on average is $2,000 a case. And you can do the maths on if you do so many per week or per year, what the case cost can blow out to be. It's quite a lot. Whereas what we want to present with Dental Axess clear aligners is a lower cost, and how you can save cost as a business, and also how you could possibly pass this cost on to your patients as well to help drive treatment. You can see we've got some numbers there. If you want to discuss any of those numbers, whether it's on a leasing plan or what equipment you may already have, please do get in touch with us and we can discuss those numbers more. So what is the clear aligner workflow? Obviously, we start with a scan first. Intraoral scanners are the way to go. There's many different scanners out there you can use. Then you take that scan and you design. Designing segments the teeth virtually and then moves the teeth into an ideal setup. You then 3D print the models, then do a vacuum form down on the models with a clear plastic, and that way you manufacture your clear aligner, and then you trim them and then pass them on to the patient at the final stage of treatment. So scanning. You could use a Trios, you could use a Medit, whatever scanner you've got, as long as you've got an STL output, that should work for almost all providers. You need to capture the upper, lower, and the bite, of course, and 3 millimeters or so of gingiva, just so the CAD software can easily segment the teeth from the soft tissue. And so when you do make your suck down, your aligner, you don't have too much of a sharp edge sitting on the soft tissue. Then the design. What do we do in the design? Well, we have to segment the teeth. This, at the moment, is done manually. I know there's a lot of software gurus out there working on an AI algorithm to take the effort out of doing all the clicking. But what we're doing here is we start off by clicking some points. As you can see in this slide here, in my points picture, I've got some discs separating each tooth, saying here's the mesial distal, mesial distal. Then the algorithm will look at that and say, I'm going to guess where the outline of each tooth is. And these are our spline lines. And then you as a human look at this and say, yes, yes, yes. Oh, no, slightly change that one. Yes, yes, yes. Once you're happy, you say segment. And then it segments all the teeth to be white, as we see here. And then the rest of it will be soft tissue. So that's the bit that is necessary, because we've got to say which tooth is which. If you've got an 8 or a 7 that's hidden by soft tissue, as you can see in my example here, it's really important that you do, as the human, look at it and go, that's where the edge of the tooth is. But this is a bit time consuming. Then once we've segmented the teeth, we move the teeth. So you can see an example here from 3Shape's Clear Aligner Studio. I've clicked on one of the central incisors and I've got some control dots. So I've got a blue dot that can extrude or intrude the tooth, some red dots to rotate and tilt the teeth, and green dots to move them around. There's also a green dot right at the base of the tooth, at the root, so you can see whether the tooth rotates here, or maybe it rotates here, or rotates here. Adjusting this green dot will give you control over where the tooth rotates. Using a CBCT scan is a really good thing to do in this particular workflow, which helps you set that green dot so you can get that rotation of the tooth correct. Once we've done the design and moved the teeth to where we want them to be, we then have to print the models. So you could start off with a big industrial $100,000 plus 3D printer if you're running a warehouse, but this is probably not the target market for today's webinar. You're much more likely to be a clinic or a lab with an entry-level printer, maybe $10,000, that order of magnitude of price, such as the Form 3B. As you can see here, there's 1, 2, 3, 4, 5, 6 times 2, 12 models that they can fit on one platform. That can do upper lower 6 times, so you could get the first 6 stages for a patient all in one print. That print there would probably take you 5 or so hours. Quite a good option to do overnight, for example. Or if you're a lab, you might want to get a mid-range printer, sort of closer to $40,000, $50,000. So you could have maybe more build platform area, whether it's sort of the size of the palm of your hand or a bit bigger, or however you wish to go, or faster as well. And we'll talk about these printing options later on. Then once we've done the printing, we take our models and using a thermoformer or a vacuum former, we get our plastic foil or filament, heat it up, drop it down onto the model, vacuum comes on, sucks out all the air, and it forms the shape over the model. Of course, you can put numbers and attachments and names, etc., so you know which line is which, but that's part of the workflow of 3D printing. But here we go, that's a very simple step. So, once over very quickly of what the workflow is, and you're probably watching this webinar because you've got some ideas about maybe I want to get into clear aligners, am I going to offer this to my customers or to my clients, my patients? There are some investment considerations. First, we have to look at the scanner. You might already have a scanner or scanners, plural. Maybe you've got a desktop scanner and you can do it with stone models even. You've also got to think about the CAD software. Which software are you going to use? Are you going to use 3Shape's Clear Aligner Studio or Maestro, or there's many other software packages out there on the market? What are the license fees involved in that? Is it $1,000 a year? Is there no license fees? Or is it a fee per click, fee per case situation? Also a 3D printer. Do you already have a 3D printer you could use? What's the cost of the 3D printer? Some considerations for the equipment. Also, the skills. You could buy the best scanner, the best CAD, the best printer, but unless you've got a skilled user driving all of it, it's no help. You can go out and buy Michael Schumacher's Ferrari, but if you've got no good driving skills, then you won't really utilize it and you won't get the result you desire. So skills is very important. Firstly, the CAD. As I said before, there's some skills involved in choosing the mesial distal of the teeth, manipulating it in 3D. There's also the skills of 3D printing, maintaining the printer, choosing the right resins, setting up timing of workflows during the day, during the night, when do you print, so on and so forth, and then the vacuum former as well, all physical skills. And then there's the time aspect. Who's going to be doing this? Will it be the doctor? Will the doctor sit there for a set amount of time and move the teeth around? Or will a nurse or an in-house technician? Who's the best person to do each of these jobs? Maybe you have a nurse do the scanning and the segmentation, and then the technician can move the teeth into place, and then the doctor can come in and say, move this, change that. Then clinical approval happens. So thinking who's going to do which tasks and in which order is also something to consider. You're investing not just in the equipment, but also the people as well. If you're going to be getting into clear aligners moving forward through 2020, you really want to think about who's going to be doing this. And at the moment, in lockdown, I'm working from home. You're probably working from home as well. Who can do the certain tasks at home? All good things to consider. So thinking about things to consider, working from home, who's going to do tasks? Do we in-house this or do we outsource it? Why not both? So if we just take a step back and we think about a name brand workflow, I'm not going to name any names, but you can see here I've got a picture of a big factory. They've got, oh, what's that, 20 printers, all well over $100,000, churning out 1 million aligners today. The workflow there is you take the scan in-house in the clinic, then you outsource the design, the manufacturing of the 3D printing and the aligners, and then it comes back in-house to you for the treatment. There's obviously a higher cost with this. You're paying off the lease of these enormous pieces of equipment. There's also the service fee. There's also the printing fee and the postage. A lot of the larger companies you can get aligners from are based somewhere in the Americas or somewhere in Europe. How long does it take for a little piece of plastic to get with a courier company and fly halfway across the world? What's the environmental impact of that? What's the time impact of that? In 2020 in April, how quickly can you get something couriered from somewhere overseas? There's also the delivery times, as I spoke about, and then the control. You don't have a huge amount of control in this particular workflow. You are outsourcing the design to professionals, but you don't have total control. You can send in requests saying, please move this. It may vary from provider to provider, but these are some key things to think about when you go with a bigger name brand workflow. What if you've got an in-house lab? Say you're a larger orthodontic clinic, say you're an orthodontic lab or a crown and bridge lab, and you have all the equipment in-house. Everything stays in-house, the scanning, the designing, the printing, everything. Maybe you've got a few Form 3Bs like in this picture. You've got a moderate cost of production. You're paying someone's salary, you're paying for all the printing, you're paying for the suck-down machine or the material. So the cost is moderate, but the advantage is you can get a really, really fast turnaround. Say a patient came in at 11 a.m. You spoke to them, scanned them, and then by 11:15, you've got a scan done and the patient says, yes, I want to go ahead. If you've got a really quick CAD technician, they could start the first few aligners, just moving the first few teeth in 10, 15 minutes maybe. Then do a print in half an hour, 45 minutes, post-process for, again, another 10 or 15 minutes, do the suck down, polish it up, sterilize, back to the patient in around under 2 hours. So you can get a patient started very quickly if you have everything in-house. So that's one advantage of having it in-house with that moderate cost of production. And in this case, say you've got your own in-house lab tech, or you are the lab tech or a very skilled CAD designer, you have complete control over the design. You can move the teeth exactly how you want them to be. Of course, they're not going to cross over, but you get the idea. You also have total control of your materials. You have bought your printer. You know exactly which material you're pouring into it, exactly which brand and thickness of suck-down material you're using, so you have complete control. But this may be a situation where you've already got some experience. Maybe you're getting into clear aligners now. This might not be you today. It could be you in a few months. Now let's look at the other option, which is probably the main likely option for the people watching this webinar today. And this is the Dental Axess Xplan workflow. So you can see here that we're starting off with the scanning in-house. Everyone knows how to scan, but maybe it's the CAD software that you just don't have the skills in yet. So you're going to outsource those, and that's what Xplan is. It's an outsourcing service for the CAD aspects of the workflow. You have a fixed fee per case, whether it's the social 6 with a set number of aligners, there's a fee for that, or more aligners for more teeth, there's another fee for that. So you've got quite a low cost of production there because your outsource fee is quite low. You can have pretty quick, fast turnaround times. You can send a scan off around lunchtime, and then the next day you should be able to have it back. Maybe the day after if it's a weekend or something like that, but it's a really quick turnaround time. The people that do the work of moving the teeth and segmenting the teeth, they can work overnight. So again, that's quite efficient. You don't have to employ someone during your daylight hours. It's done for you by someone else working in a different time zone. So that's a very good use of resources as outsourcing. And also you do have total control of the design. If you want, you can move the teeth, and we'll show you that very shortly, or you can say, please move this tooth here, and it will be moved for you. You also have total control over the materials. As with the previous example, you have the printer, you can choose the material, you could choose the thickness of the plastic, clear plastic for the aligner. So this gives you a huge amount of control. And I think this is a really good workflow for people that are just getting into clear aligners, as they may have the scanner, they may have the printing equipment, but they may not have the CAD skills necessary to segment and move the teeth into the desired location. So let's talk a bit more about Xplan. So the time savings, obviously I spoke about the time savings, not having to employ someone with CAD skills. You can outsource this and it's done by a professional overnight, and that way you can free up your time and your staff's time to do other things, whether it's seeing more patients or doing other work around the clinic or the lab. There's an online portal, which we'll look at in a moment, where you can track the progress of all your cases. There's a dashboard, you get notifications. As I said before, you can have the professional CAD designer do the movements for you, but you can also make changes yourself. There's a patient communication option as well. We'll look at that too. And manufacturing support. As you can see down the bottom right, there's a huge number of models there, I'll say 10 or 12, and they've all been stacked accordingly with the little support bar made ideal for 3D printing. So let's quickly look at this again. Xplan workflow, you outsource the segmentation, you can save your staff's time, you don't need to upskill, you can also outsource the design if you so choose for the teeth movement proposal, and then the doctor, as the clinical professional, has to say, yes, I approve, or please review before approval. So let's do a live demo. Here is the Xplan portal, xplan.dentalaxess.com. You can see this is my account here. I've got a few patients that I've made earlier, just like any good television chef. Here's one I prepared earlier. But let's do a new patient. So up the top left of screen here, I hope you can see the gray circle. We're going to go to patients, and I'm going to create a new patient up the top right. We're going to call this Lockdown Webinar. I can choose the office I'm in. I'm going to say I'm Dental Axess New South Wales today. We can give them a date of birth. We can choose the lab we want to do the printing for us. That's an option. Then we say next. So I've made the patient. I can add some images here. So maybe one with a retractor showing the patient's teeth, a few intraoral photos as well. So with the mirror and the camera, getting a nice occlusal view of the teeth showing how they currently are. This will help the CAD team work out what you want. So really good to add some photos there. Also some front-on and profile photos, whether you're correcting a overbite or overjet, whatever you'll be doing. It's a good way to show the team how you're going to be moving the teeth around and what the current setup is. Next, I have to choose what I'm doing. I'm going to say aligner and who designs. Let's say Arcade designs. Who prints? I print. There we go. Pretty simple options. We'll say next. You've chosen that Arcade will prepare the models for 3D printing, and then I will print them myself. So a little sanity check here. Is this what I want? Yes, it is. Then we say next, and we will submit the case. Now I've made a case, but there's no patient scans. So I can go back to my particular patient here. Let's wait for this to load, and I can upload the scans manually. Say I've got STLs from a scanner, I can do that. Or I can choose, if I want, to upload from an intraoral scanner. So say you've got a Trios that you're using, or a Medit, or any other scanner, you can send scans that way. You can then fill out the order form as to how many teeth you're wanting to be doing. Let's go to orders. We'll double click on this order, and you can see here impressions. How am I sending? So sending directly from scanner, I may have a Trios or another brand scanner, or I can upload the STLs digitally. Here's my upper, here's my lower, here's my occlusion, or if you really want, physical models, but this is 2020, we won't bother with that. So let's look at this order form. Treatment type, express, limited or unlimited. So we'll do express. I'm going to say single arch only. In sizes, I have some options here to choose, same with overbite and overjet. Many, many options you can choose, but I'm not going to bore you all with the filling out of an order form. Let's look at a case. So I'm going to go back to my patients, and I'm going to choose Xplan Webinar. As I said before, here's one I prepared earlier from a webinar I did last year. Here we can see the patient information. I can go to orders, and here's my order. And you can see here the status is doctor review. So that means that I've done the scan, uploaded it, and then the CAD team have segmented the teeth and moved them into position in somewhere they recommend. And now it's up to me as the doctor, of course, I'm not a doctor, this is a demonstration, to review this and either approve or ask for a review. So what I'm going to do, I'm going to go up here to the top right of screen, see the little 3D symbol with the computer on it. I'm going to double click on that and it's going to open up some software, and here I can look at how the teeth have been moved and review the proposal. We can see up the top left, there's the patient webinar, and we can see here, there are the teeth. This patient doesn't have any lower lifts, but we can see down the bottom here, there is 1, 2, 3, 4, 5, etc., etc. This is a little timeline. So if we look at the lower jaw only, and I hit play, we can watch a little video of how the teeth were, and then every step we see how the teeth moved into an ideal setup. So this is a really good tool you can use to show your patients, or you as the doctor can see this as well. You can provide a web link so the patient can see this and say, yes, I like this, or no, I don't. I think my canines need to be different, or whatever it may be. If we go to the right side of screen, we've got a few options here. We can make the teeth more or less transparent, as you may be familiar with other CAD softwares. We can show some patient images, as I spoke about before. We can hide the gum if we really want. We can overlay an arch form if you want to use that to guide. We can show teeth collisions if necessary. We can superimpose how the teeth were. So this is a really nice example of saying, this is how the teeth were, and you can see this is the front teeth. They were a bit off, and they've been moved into a much nicer alignment. So this is a really good tool to use to show the patient, this is what's happening, this is how we wish to move your teeth. Symmetry, if we look from the front, we can also use symmetry as well. There's an occlusogram to show like a heat map of how the teeth are. We're just going to bring the upper back in and move that back into place. And you can see here, actually, maybe if I look from the perspective of the tongue, we can see the contacts in this particular patient's teeth. So there's a heat map showing the distance for those particular teeth. Grid lines as well, if you want to have millimeter spacing. A Bolton analysis, this is very popular. People love to look at the Bolton analysis and read the numbers. Those orthodontically trained will understand this. So that's a very brief overview. Up the top right here, I could approve this if I was happy with this, or I could do some revisions. So I could say, please adjust tooth number, so forth, move distally, etc., so on and so forth, whatever I wanted to type in, and then send the comments. The CAD team would then review them and make the changes and send back for approval. Or I could do these changes myself. Up the top left of screen here, we have edit mode. So I can click on edit mode, and you can see the background goes from blue to white. So a nice little indicator for your mind saying, oh, I'm moving the teeth. And I'm going to click on, which tooth should? Let's hide that there. Let's click on this particular tooth here. And you can see it's green and it's active. And I've got some circles and some arrows. So I might say, I want to, up the top left here, I want to move this tooth out. I'm moving it out every time I click. I might want to move it mesially or distally. Maybe I'll look from the front. Maybe I want to extrude the tooth slightly. Maybe I want to tip the tooth one way, tip the tooth the other way. So some very simple tools, just 3 axes of rotation, 3 directions of movement. Move your tooth however you wish. We could reset the aligner back to how it was originally. So that goes right back to how it was. Of course, this isn't very likely because that tooth's colliding. I can spin it, move it however I wish. I can also extract the tooth. So do I want to extract it? Yes. Gone. Tooth is gone. We can set aligner speeds as well. So I can say, never move the tooth faster than maybe 0.1 millimeters per aligner. Rotations, let's say 0.2 degrees per aligner. So you can set these do your movements, and it will recalculate the number of aligners required. And you can see down the bottom of screen here, it's gone from 13 to 11 due to me extracting that particular tooth. So it'll update on the fly. We can also do attachments as well. So let's do attachments on stage 5. And we can play around with a bunch of different attachment shapes, as you can see here, whether you want a dome or a wedge or this arch used to pull up or rotate, whatever you wish. There's a huge range of options we have available. So you can play to your heart's content if you want to do this movement yourself, or if you want to subtly change the suggestion by the CAD team. So that's a quick overview of the software you can use to move around, and you can see it's very simple to use, lots of really helpful tools. So let's go back and look at, oops, wrong slide. Let's go back and look at what happens once it's been done. So I'm going to go back to my patients. As we saw there, the doctor review case is in that particular status. The one I created before is records review, which means the CAD team are looking at the records. Waiting on impressions is another one. And here's one I've got here called test 1, test 2. That's doctor review. Another one for my colleague Per that's been cancelled, and one called model print. Test 2, test 2. So let's look at test 2, test 2. So I'm working on the assumption that I've made the order, sent the scans, teeth have been moved, and I, as the clinical doctor, have said, yes, this is what I want. Now the models are ready for printing. So I'm going to double click on this case here, go to orders, and we will see here that again the status is model print. That means I can now go to this printing tab up here, and I can click there, and it will give me all the different models for this particular case. We can see here we've got 12 aligners, and there's aligner 0, 1, 2, 3, etc., etc., etc. What I could do, say I wanted to do the first aligner today, maybe the second as well, I can just click download. And we can see that's going to download in the bottom. It's a 6 megabyte file, really small. And I'm just going to quickly open this on the other screen. I'm going to bring it across to the main screen in a moment. And there we go. There's my model ready for printing. So you can see it's got the patient's ID, L for lower on it, which is really helpful. But I don't need to tell you that this is a lower jaw. And also what's really helpful here is this 0, which is aligner 0. Obviously, if I printed aligner 1, 2, 3, etc., they would have 1, 2, 3, etc. So you know when you do the suck down and do the printing, that which one is which. Obviously, when you're printing and you post-process all your models, they're going to get mixed up. So having this numbering system here is really helpful. What we also see is a nice flat base. This shiny base tells us that it's a perfectly flat base, which is really good for printing. Or we can also see there's a big fat edge on the back, distally off the molars, if you wanted to print them standing up. That's all good if I want to just print a few, but what do I want to do? All of them. What do I want to print all the models today and then make all the aligners today? I can click Add All to Cart up the top right of screen, this yellow button. I click Add All to Cart, and you can see they've all gone gray. And then up the top right of screen again, next to my name, there's this 23 in the print cart. So I'm going to go to the print cart, and we can see here they are all. I can choose which printer I've got if I want. So maybe I've got a Structo Dentaform, if you're doing a lot. Maybe you're just getting into printing. You've maybe got an Asiga Max. All the different printers that are popular are listed here. I can say Structo Dentaform. Maybe I want to hollow them to save a bit of money on resin. I can cut the base. Nesting, I can choose to have them all set up for me, nested, or I can say do not nest. I'd rather do this myself. Totally up to you. We can also say print vertical if you want to stack them all vertical to get more models onto the same print job. And you can see this will be approximately 3 files. A thickness for the hollowing, lots of really good features here that you can play around with. I can then say create print job, and then these will go off to an automatic algorithm in the cloud, which will set them all up as you choose and send them back to you. And again, because I'm a fantastic TV chef, I'm going to show you, here's one I prepared earlier in the oven. I'm going to go into the left side of screen here to print jobs. And I've got one that one of my colleagues has made recently. Thank you, Eric, for all your hard work. Double click on this one here. And you can see he's got 5, 4, 4, and a few more. And of course, we could download these. Only takes a minute or so. And they will all come out as one big job ready for you to print. Because I've done this before, I'm going to quickly show you an even bigger one. So jumping again, now we're looking at NetFab. This is one I've set up previously for the Structo. You can see I've got them all standing up. You can see they've all got these large, thick support bars here to ensure that they hang on to the print bed during the print process. Quite a complicated one we see with a few attachments, some wedges, some arches. They're all hollow. We can see we've got a patient name there. We can see we've got numbering on the molar. See, there's number 16. So this is really easy. I can just set this up and you can see it all fits perfectly into the print bed. I could probably fit a few more on here, but this example, I just chose this many here. So again, these efficiencies are really good. Really cool options to use if you're going to be printing in volume. So that's a very quick overview of Xplan Live. Let's go back to the PowerPoint. So we've done our live demo. Let's quickly talk about the Xplan workflow further. So printing models. If you're in Office 3D printing and you're looking just to get into printing, you might look at something like the Formlabs Form 3B or possibly even the Form 3L, which has a much bigger build platform. This has a lower entry cost, lots of different materials. There's biocompatible ones as well. So whether you're a Crown & Bridge lab who does Crown & Bridge models, you might do temporaries, you might do surgical guides, you might do RPDs. You can just pour in a different material to print your aligner models. Quite simple machines. They're yay big, maybe 40 centimeters by 40 centimeters. So it's scalable. You'll use the same software. Once you find your volume is more than you can get out of your printer each day, you can simply add another printer next to it or another one next to it as well. And the workflow is integrated. So if you're using 3Shape's Clear Aligner Studio, you can integrate the printing in there as well. And of course, as we saw with Xplan, you can also integrate the setting up of the models onto the particular tray. This works using a laser and a mirror, which cures some resin and it lifts out of the platform. Really good option if you're just getting into printing for under $10,000. Say you're a bit more serious. Say you're an orthodontic lab that does lots of models a day, or you're an orthodontist with an in-house lab. You might look at something like a Structo or a Rapidshape, much bigger build platform. As we just saw a few minutes ago, you can fit tens of models on the platform. And this is faster because it uses a projector or MSLA technology where you expose an entire layer at a time. Some of these even have integrated post-processing. You don't necessarily need support materials because you've got this big build platform with that bar you saw in NetFab as well. We really think this is for people who are doing a high throughput of orthodontic models or other models as well. If you're a really serious business, you can go with the Structo Elements. This is a bit of automation from Structo out of Singapore. There's 2 dentaforms inside and a bit of robotics as well with cleaning using isopropyl alcohol and UV light to cure the models. So they come out and you might be able to see in the picture, there's a bunch of racks here on the side, which a tray on each one. And you can just run this 24 hours a day. So if you're a serious business, you can go one of those. If you're super serious business, go with many elements stuck together. Or if you're serious business and you want something German, go with one of the Rapidshape D100 plus orthos. You can see they all line up and they have a conveyor belt through the middle where after each print is completed, there is a scraper that scrapes all the models off the platform and they fall down onto the conveyor belt and then off they go into the post-processing workflow. So if you're getting really, really enthusiastic and want to get crazy high volumes, consider something like this. Or if you're just getting into printing and clear aligners, you might want to go with an integrated post-processing method, such as the Rapidshape Cure and Wash. This is really cool because the printer will talk to the Cure and the Wash and say, I printed this material. And so you walk over to the wash and you say, it was this job, which was that material preloaded. So it's all done for you. In this little unnamed box on the side, there's 2 bottles of IPA, and there's a clean wash and a dirty wash. Then you take the bottles out, put them in the cure, shut the lid, and it has a vacuum that can suck out any oxygen to ensure you get a really nice cure on the model surface. This is obviously less mess. It's all self-contained. Same with the form wash and the form cure that we see down the bottom, the 2 black boxes. There's the ballerina example, and it's quite a tall model, so you can imagine if you're doing a huge number of stacked models, which is coming very soon, this can ensure you get all the models washed at the same time. And also measuring systems indicating when the IPA needs to be changed. So in the case of the Rapidshape, the clean and the dirty, and in the Form Labs, you have a hygrometer, which is a little float device. So really nice, clean ways of doing the post-processing. If you're a clinic, you want to keep it quite self-contained, maybe in one room in the back, and that way you have a nice setup there. What about 3D printing materials? Well, there's obviously models for clear aligners. You can use a model material as long as it's accurate enough, and you could use 150 or 200 microns as your layer thickness. As long as it's a good material that's not too brittle, but it can be fairly cheap. But what about if say you've grown out of clear aligners in the orthodontic world and you want to get into indirect bonding trays? You might need a biocompatible material there. So there's constantly materials being worked on, and other developments as well, whether it's for crown and bridge or whether it's for other options for orthodontics, such as the salt and pepper materials as well. There's always new materials going on, so that's quite exciting. Delivery systems are very cool as well. So you may have seen at IDS last year that Rapidshape came out with their capsule system. So instead of having to buy a whole liter of material or a few liters at a time, say you only want to print a few models, you buy a smaller, maybe 100 milliliter or less volume bottle and an independent little tray, and you can do individual prints at a time. Or maybe you're doing a huge amount of aligners and you've got liters and liters of that, but someone says, I need an IDB tray, and you don't have liters of that lying around. You could use this capsule system as a one-off to quickly print whatever it may be that you need to be done. Or if you're doing some orthodontic appliance, which you need to print, invest and cast into chrome or some other material, and you don't have liters of that lying around, you could look at this capsule or cartridge option too. Here's some nice examples. So here's an IDB tray. There's many different shapes and designs. Some of you will have seen the ones that totally enclose the bracket. Some are like a rod that goes around that looks like an arch wire with the little bracket holders on. Also, there's some aligner materials. We're all waiting for the day that you can print aligners directly, but I think that's a few years off. So we've spoken about the Xplan design workflow, the model printing workflow. Now let's very quickly talk about manufacturing of the clear aligners themselves. As I spoke about earlier, you can have total control over which particular material you use, if you so choose. And depending on what size of thermoforming machine you want, you can, again, just get a regular ErcoDent single at a time, or they've got this ErcoPress 240, which we saw at IDS last year, which is a bit bigger. Or there's a red one there. That's from Dreve, and you can see that is very serious business. They've got quite a few models on there, and I imagine you could get really enthusiastic and try and put even more on. Or if you're like an Elements from Structo, you could invest in some machine that does it automatically on a conveyor belt. So you can see how clear aligners can really scale very quickly, and depending on how many you wish to do per week, there's always equipment available for you. And this is something I just wanted to finish up on, the aligner cutting machine. Some of you may have trimmed aligners before. You have to cut it out with some scissors and then get in there with a knife and delicately do that. There's quite a bit of skill there, quite a bit of time per aligner. It's not easy. It's not necessarily fun. We're looking at new options for automation. So you can see this is something we showed last year at the AAO in Los Angeles, is a Roland 52 DCI. And we, along with some of our colleagues, have made a little aligner cutting option. So you can see here, the tool goes around on a predetermined path and cuts out the aligner for you. Obviously, the advantages here is efficiency. You don't have to employ someone sitting there cutting out each aligner a day. You have a machine that can do it. Load it up with as many different aligners as you can into all the pucks and hit go, and then the person can do some more work while that's being done for you. I don't know whether it's efficiency or just clever laziness. Anyway, thank you very much for attending the webinar today. If you do have any questions about clear aligners, please do reach out to us. We're on all the social media. Send us an email, give us a call. We are still around during this lockdown, working from home. So please give us a call if you have any questions. Thank you very much. Bye.